All right, so we are going to create a script that spawns a random number of objects around a room, around several rooms, and each one of those objects are going to be either good or bad objects to pick up. The player is going to run around collecting them, and some of the objects will do nice things and some of them won't. This example project or I don't know, lesson helps us talk about how to have one script, the player controller, talk to another script, the object, and the spawner script also talk to the objects and create objects from nothing. So let's get started. Here I am with the player controller, and my Unity scene is still baking its lighting, but that doesn't mean we can't get started. So what we want to do is in this room here, I'd like to build a spawner right in the middle, and I want to specify a distance. So we're going to create, let's say, just a cube for now. And I want to be able to move it anywhere inside this room. And so we're either going to create it, plus 20 meters or minus 20 meters and plus 20 meters or minus 20 meters on the X and the Y axis. Let's start there. So right... Come on, you can do it. Actually, this might take a while. So let's go here and let's create a new file. I don't remember what all the includes are going to be. Let's copy it from the top. Okay. Let's just copy all of these. Control V. I don't need these two. And the name needs to be item spawner. Okay, let's save this as item spawner.cs in the scripts folder. And let's have a void start that says debug.log spawner is starting up. Just to make sure it works. Okay, it's going to continue to think. So let's create a function called void spawn item. So the return type of this function is void, so it's not going to return anything. There are no input parameters. You don't have to call them input parameters, just call them parameters. But I want you to know as you're learning that parameters are where we get our inputs in our function. Name of function is spawn item. Hopefully that's really obvious. Let's add a debug.log that says spawning item. Let's see. So there's two ways. We could create an object from a prefab, and I think that's the way I want to do it. So let's build a public game object item prefab. And we're going to say game object item is equal to instantiate item prefab. So that creates an object, a copy based on this. The same thing that happens when you press Control D when you're holding an object in Unity. That is what our script is going to do. So I wanted to get roughly in the middle of the room. And so if I select the 4 of these, that will roughly be the right spot. I am going to press F to focus and go to Game Object, Create Empty. And this will be named Item Spawner. And I'm going to add component, Item Spawner. And here it has an option for a item prefab with a none game object. So I'm going to go ahead and build that item. 3D object cube. And I will go ahead and add a rigid body so that it falls to the ground. And I'll just rename it item. And let's go ahead and tag it as an item as well. So let's add the tag item and save. Back to this and set it to an item. And then with that completed, I'm going to drag this to my prefabs folder. And then I can delete it from the scene. So here's my item spawner. I'll set it to have a specific UI so it's easier to see. And I will drag that item prefab from the prefabs folder into that spot. Okay. So let's have a look at our code. Let's go ahead and just see if it works. So we're just going to call spawn item right here, and in void start it's going to spawn a single item. It's always good to test this as soon as you can to catch things early on, and you know, when you're learning, you just want to see how this works step by step. Okay, well, I need to turn off maximize on play because I just want to see what's right there. Boom, there's our item. We can select it. It's called item clone, and it's tagged as item. Okay. So what else can we do? We wanted to move it next, right? So right after we create it, let's say item.transform.translate, and we'll say random.range, let's say -2 and 2 on the x-axis. On the y-axis, let's just make it 2. And on the z-axis, also, random.range, -2, 2. So, this is x, this is y, and this is z. Let's see what that does. Okay, so it jumped it in the air and then landed it right here. Let's see if it's random by doing it again. And it moved. It's not in the same place. Let's make sure we can get it over on this side as well. Yeah, there it is. Perfect. Okay, so instead of spawning one of them, well, let's spawn 10 of them. So we're going to build a simple loop. One of the good loops for doing something a certain number of times is a for loop. For int I equal to 0. So I is just a simple variable name that could be anything. You could think of it as a counter. It's I for iterator, just because it's going to iterate a certain number of times. But as long as I is less than 10, keep looping. And every time you loop, add 1 to I. And then inside we're going to call the spawn item script. So we can add a comment here that says that this is going to create 10 items. Or call the spawn item function 10 times. Let's see what this does. There we go. Nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's start to make this tool a little bit more generic. We want to be able to change the range and the height and the depth that we're going to move it. So let's build a public float X range and Z range. A public float height. We can default it to 2. We can also say that the X range is equal to, let's say 2 for now, and also equal to 2. And you might be thinking, what about the min and the max? Well, we're just going to take X range and make this negative X range. We can call this the height. And this is the Z range. I'll show you a trick. If you're using Visual Studio Code and you press Alt, you can click in 2 places and type in 2 different places, which is really neat. Okay, so if X range is 2, then this is negative 2 and 2. If height is 2, then this is 2. And I did X range when I meant to do Z range. So there's Z range. And those should also be 2. So this should be negative 2 and 2. 2, negative 2, and 2. So let's see what we get with that. Make sure it works the right way. Okay, good. Super good. So what else can we do? Let's go ahead and just try to change those ranges now. So here's the item spawner, and now I have these values, and I can begin to edit those. So if the item spawner is at negative 22 on the X, negative 24. Oh, I'm sorry, this is on the Z. So an item spawner, you're at 18. This one over here is at negative 4. So I'm going to say at least 20 on the Z range. And then on the X range, if you're at 22 and you're at 12, let's call that 10. And let's increase the height to something like 4 just to see what happens. I'll hit play and I'll see where they all spawn. Okay, good. Let's hit play again and make sure they don't spawn outside of the room. Good. Good, they all seem good. Let's be able to change how many we create. So instead of 10 every time, let's make that public. So public int total boxes, or let's do box spawn amount. And so maybe in this big room we actually want something like, 60. So we made the box spawn amount here, but we didn't change it in our for loop. So once we change that in our for loop, now it'll update. There we go. And what if we did this more times? Something like 600 times. Oh, not 6,000 though. That's too many. That's quite a mess. Even 600 though is It's not even multiple layers, really. One of the things that I don't like about these boxes is that they're all very dark, and that's because this scene is using these emissive lights, and the boxes basically aren't receiving any of that. So what I'm going to do very briefly, I'm going to talk about light probes. And I think I'm actually just going to add a light probe group to the spawner. Maybe at the same place as the spawner. We're just going to go to create empty. I'm going to call this light probes. I'm going to add a light probe group. And it's just going to create these light probes. And when the lighting bakes on these light probes, I do not want to make the lighting bake again. But when they do, they will add their light to the moving things in the scene, new things in the scene. So hitting play right now shouldn't do anything because I need to bake the lighting again. So let's pause and I'll go do that. So lighting, generate lighting. Oh, did I make that static? I wonder if that matters. That might matter. I might have to make that static. Well, or for some reason the universal render pipeline doesn't do light probes the same way. So we'll just skip the light probes, I guess. If we go to environment, turn on environment lighting, is that going to make a difference? What about... I don't know, actually. I'm not sure how to fix this one. We can always add real lights. You know, we've got a few in our scene. We could probably add some sort of directional light. "3D object, light, directional light." That would make everything really bright. We could turn off the shadows, and we could set the intensity down quite a bit, something like 0.3. And if we hit play now, would our boxes be more reasonably lit? Not really enough to match everything else, frustratingly. Here's our directional lights. As we increase this to 1, they get a little bit brighter, but these are supposed to be white. Oh, I guess they are medium gray. Well, we can at least make them not medium gray, I suppose, but still, I'm bummed. I do not really want a directional light in my scene. I guess we'll just have to figure something else out. Maybe we can hand them a different kind of material. So I'm going to go to my prefabs folder, maybe. Or I guess I'll just open the prefab here, try to give it the material that I want. Ceiling. Okay, the boxes are at least all much lighter in color now. And I'll take that. That works for now. Okay, so let's build a reasonable amount. Maybe 200 boxes. What does that look like? So many. Let's try something like 50. Let's try 30. If I think about how many, the player needs to get to, then that's, enough to go clean up. Now they're kind of hard to see against the ground, but we're going to change their color anyway, so let's just keep playing. Okay, so we need to be able to pick up these boxes. But I said that I wanted to check whether or not they were a good item or a bad item. So let's attach a new script that just has a couple of variables, maybe one variable that says is good. So on the item prefab in your assets folder, let's add a component called item details. Maybe item data. Doesn't really matter. And when we open that up, let's go ahead and delete void start and void update and just have a public Boolean is good equal to true. And then in void start, every time one is created, how do I make this random? If random dot value is greater than 0.5f, is good is equal to false. So random.value gives us a number, a random float between 0 and 1. And so if that number is greater than 0.5, then is good is false. And we can do something like get components. Actually, let's just change the name. This.gameObject dot name is equal to bad item. Okay, love it. But let's put this inside the if statement. We'll have an else statement here that says this.gameObject.name is good item. So if it's greater than 5, it's a bad item. And if otherwise, it's a good item. And we can do things like change their colors from red to green. Let's just go ahead and do that. Get component renderer dot material dot color is equal to color dot red. And we'll copy and paste that. Color dot green. Let's do blue. Let's see what that does. Because it's on every cube, every time we create a cube, it automatically runs. All right, red and blue cubes. And red are bad items, blue are good items. So let's go ahead and look at our player controller and talk about picking those up now. So I'm going to put item data on this side and look at the player controller. So in the player controller, down on trigger enter, if we run into a key or a door or a respawn or a finish, and next will be if other.gameObject.compare tag item. We're going to say if other, we need a reference to it. Other.get component item dot is good is equal to true. Type our name is item data. There we go. So make sure it's item data, not just item. If other.getComponent item data is good is true. So we're talking about this one right here, and this is how we access it. So we know what other is. That's the collider of the thing that we just ran into. We're asking to get the component item data, this thing, from that other thing that we ran into. And then we're looking for the variable is good and checking to see if it's true. And we don't technically need this because this whole bit is going to return true or false. It's just going to be true or false. But let's say if it's true, cout collected a good one. And we'll have an else statement here, and we'll just say collected a bad one. Okay, in either case, we're going to collect them. So we can say destroy other.gameObjects. And I think we should just add to a counter. You know, I collected this many good ones, I collected this many bad ones. So let's scroll up to the top of our player controller code. And we will use, okay, we've been using serialized field. That's nice. So we've got total keys here. Let's add a couple more. Total bad items equal to 0, comma, total good items equal to 0. And this will just show up in the inspector and tell us how many we have. Maybe later we can add some UI to say how many we collected. So once that's added, we'll say total good items plus equals 1. Collected a bad one, total bad items plus equals 1. And then we destroy the thing. Okay. So let's hit play, and we'll actually try to collect our boxes now. I don't know why my keys aren't working. Oh, we've got a script missing. Did I mess up the player controller somehow? Oh, I think I just moved the player controller. And Unity didn't notice. So, collecting a key, opening the door, walking through. Oh, I wonder why that reset. It's very interesting. Oh, escape must do something to that effect. So, if I walk in, I collect the blue one. And we should be able to watch the player capsule. And if you have a look over here under total good items and total bad items, this should show up. So collected total good items, collected bad items. It doesn't have to be good and bad items. We didn't need to bring in, you know, judgment into this. We could have just said red and blue items. Oh, I must have hit a bit of lava. So when everything's working the way that it should. When I run into this thing tagged item, I'm calling this item data, which is talking to a different script, a different component. And then it's adding these here. And as long as this is public, we can set all of that. Let's add a little bit more randomness to this item data script. So if it's a, regardless of what it is, let's go ahead and say that the scale of these objects is randomizable. So if we say this dot transform dot local scale is equal to vector3.1 times random dot, here we'll bring this back over here, random dot range between, let's say, 0.5f and 3f. 3 might be a bit much. But what this line will do is it will randomize the scale of all of our boxes. There we go. And 3 meters is taller than our player, so maybe we'll like limit that to 2f here. Let's go ahead and go to our item spawner script for a moment. We do a translate here, but I'd like to set the item.transform.rotate. Vector 3 Oilers. So let's do random dot. Can I do random dot rotation? Lowercase r. Can I say that rotation is equal to a random rotation? That one might work. So item.transform.rotation is equal to a random rotation. Let's see if that just randomizes the cubes. They should all fall back down flat, but they can at least change how they're oriented at the beginning. Yeah, that's pretty nice. It also changes their rotation on the y-axis, so they're not all facing exactly, you know, north or south or all of that. Okay, back to item data. What I'd like to do is I'd like to call a function that instead of destroying them immediately, they just shrink down to 0. So in the item data script, after start, this is the end of start, we're going to build a public void. How are we going to do this? So public void get collected. And this is going to just call a coroutine, I suppose. So let's say IEnumerator get small. And we will say while true, yield return new, wait for end of frame. That should work. Maybe this. Okay. And this is just going to say start coroutine get small. Okay, so the idea is that the player controller, when it runs into this, instead of destroying it immediately, it will destroy it over some amount of time. And the getCollected function will call the IEnumerator. And the IEnumerator will make the... make what? Make the object, the item, get smaller over the course of some amount of time. So if we did something like this.transform.localScale minus equals vector3.1 times 0.5 01F. So it's going to get 1% smaller. And then it is going to wait for the end of the frame and loop up and get 1% smaller, and so on and so on and so on. And let's say while this.transform.local scale is greater than 0.1f. Maybe .x. Okay. Once that's done, then we'll say destroy this game object. So this is going to get smaller and smaller and smaller. Once it gets down to a tenth of its size, it will break out of the loop and then destroy itself immediately. Let's see if that works in action. I don't think I updated player controller to, instead of doing this, say other.get components item data dot get collected. Okay, so this is me calling the get collected function on the item data component of the thing that we run into. Get a key, open the door, hit this blue box, and it gets smaller and then just goes away. And that's really juicy. That feels a lot better than just having them disappear. And the bigger ones take longer. And that all just feels a lot better, even for just a little bit of work. And they even get smaller. Their collider gets smaller as I'm pushing. That's awesome. So some other things we could do if we wanted to. I'm going to keep this video short, but one of the things that I'd like to do is I'd like to have each of the boxes, if they hit one of these respawn points, they should just destroy themselves. That way there isn't any boxes. There aren't any boxes that are in the lava. It doesn't seem to make sense to me. Okay. So what I want you to do is I want you to take this item spawner, duplicate it, and move it to every room but the first one. And what you need to do is change the size. So if this is a 9-meter room, it can go maybe 4 meters and 4 meters. So on the X range, 4, the Z range, 4, the height, let's say 2, and let's have it only spawn like 6 boxes. And we hit play. Okay. I'm wondering, I skipped a step because I thought I wouldn't need it. Yes, look, all the boxes are being spawned in the same spot, and that's not what I want. So we need to move them to the specific spot, this box spawner here. They need to be spawned here and then moved. So one more line of code in the item spawner. We are going to instantiate them. Here's that line right there. And then we're going to say comma transform.position and transform.rotation. And that is going to set the item, the copy that we made, to be in the same spot as the spawner and have the same rotation as the spawner. And then we'll move it, and then we'll rotate it, and that should fix the issue that we were running into. So, Control P to play. There they spawn in the right spot. That's what I want. Let's turn this one on. Let's just duplicate it for this other room. Hopefully there looks good. Let's press Control P to test it. There we go. Okay. I hope this helped you learn a little bit more about how to create functions and then to have them call other functions, even if they're in other scripts. Let me know if you have any questions, and I'll see you next time.